All right, welcome to The Explainer. Today, we are tackling a big one, the Chinese language. I know, it can seem incredibly complex, right? But what if I told you to think of it less like an impossible mountain to climb and more like a really fascinating puzzle? And today, we're going to hand you some of the most important pieces to start solving it.
I mean, this is the question, isn't it? You've got all these characters, thousands of them, sounds that are totally unfamiliar. Where do you even start? It feels overwhelming. But here's the secret. There is a hidden logic, an underlying code to the whole thing. And if you stick with me, we are absolutely going to crack it wide open.
Okay, so here's our game plan. First, we're going to look at what I call the aspiration trick for sounds. Then, we'll see how sounds are grouped, going from your lips to your tongue. After that, we dive into the characters and their building blocks. And we'll wrap up with a really cool system, a code for every corner. Let's get started.
All right, section 1, the aspiration trick. So our first piece of the puzzle is all about the sounds, the sound code. Now this is usually the first big hurdle for anyone learning, but it's actually built on this really neat, super consistent idea. We're going to start with two syllables that seem almost identical, but have one crucial difference. Okay, so look at these two. The first one, da, sounds pretty much like the D in the word day. No real puff of air, right? Da. But the second one, ta, this is where the magic happens. Put your hand right in front of your mouth. Now say it, but really push out a little puff of air. Ta. Feel that? That little burst of air is called aspiration. And in Mandarin, that puff of air is literally the only difference between the D sound and the T sound. It's not about the letter, it's all about the breath.
And get this, it's not just a one-off trick. It's a pattern. It's a rule in the system. Check this out. Bull, unaspirated, no puff of air. Now, what do you think po is? You got it. It's aspirated. You get that same burst of air. Pull. See? It's the same exact logic. Once you grasp this idea of aspiration, you've basically unlocked one of the most fundamental patterns in how Mandarin sounds are made. It's a huge piece of the code.
Okay, section 2, from lips to tongue. So we've just figured out how some sounds are made, with that puff of air or without it. Now let's talk about where in your mouth they're made, because this reveals yet another layer of organization in the language. And honestly, it's way more systematic than you'd probably guess.
So take a look at these sounds, the ones we just practiced. Bo, po, and also mo. Try saying them. Bo, po, mo. See how your lips come together for all of them? That's why they're called bilabial sounds. Fancy term just means two lips. Now try these other ones. Da, ta, na, la. Where's your tongue? It's right up behind your top teeth every single time. Those are alveolar sounds. So the language is literally organized by your anatomy. It's not random. It's a logical map of your mouth, from your lips to your tongue.
All right, section 3. Characters have building blocks. We've cracked a big piece of the sound code. Now we're going to pivot to the part that, let's be honest, intimidates a lot of people, the characters. But just like the sounds, there is a system. It's not about memorizing thousands of random squiggles. It's all about recognizing the building blocks.
And the absolute key to this whole system is one concept, the radical or busho. So what is it? A radical is basically a core component that you'll see again and again in different characters. Think of them like Lego bricks. Instead of memorizing thousands of unique, complex structures, you just learn to recognize the same handful of bricks. And here's the best part. The radical often gives you a massive clue about what the character actually means.
So, how many of these Lego bricks, these radicals, are there? Well, the standard set has 214. Now, I know 214 might sound like a lot, but think about it. Learning 214 pieces unlocks a vocabulary of thousands of characters. It's a pretty good deal. And hey, for anyone who likes fun, useless facts, here's a weird way to remember it. 6 to the power of 3 minus 2 equals 214. A little bit of math to help you with your language learning. Why not?
Let's make this super concrete. See that little 3-dot symbol on the left? That is the water radical. Now look, here it is in the character for river, hu. And here it is again in the character for sea, high. And what do you know? Here it is in the character for lake, hu. So even if you've never seen these characters before in your life, the second you see that little 3-dot symbol, your brain can go, okay, this probably has something to do with water.
It's like a secret clue to the meaning hidden right there in plain sight. Okay, section 4, a code for every corner. So think about what we have now. We have patterns for sounds, and we have building blocks for characters. But I want you to imagine something. It's the 1920s. There are no computers, no search bars. How on earth do you organize a dictionary with thousands of these incredibly complex characters? How would you even look one up? It's a huge problem, right? And it required a solution that was nothing short of genius.
And that genius solution was called the four-corner method. This thing was developed way back in the 1920s, and it was a brilliant answer to a massive problem. Basically, a data organization problem, long before we had a digital age. What it does is it provides a method for turning a complex visual shape into a simple number that you can actually sort.
So how does it work? Well, it's actually beautiful in its logic. The system assigns a number from 0 to 9 to different types of brush strokes. And then you just look at the character's four corners. You start at the top left, you go to the top right, then the bottom left, and finally the bottom right. You identify the stroke in each corner, assign it the right number, and you've got your code.
Okay, let's use a real example. Take this character, Da, which means big. So, using the four-corner rules, you look at the top left corner. That shape gets the number 4. The top right corner, well, it's basically empty, so that gets a 0. The bottom left, that little fork shape, gets an 8. And the bottom right is also considered empty, so it's 0. Put it all together, and the character for big becomes the code 4080. And just like that, you could file it in a dictionary. It was basically a pre-digital database, just an amazing testament to human ingenuity.
And there you have it. Think about the journey we just took. We went from a tiny puff of air that changes a sound to Lego brick radicals that give us meaning, all the way to a numerical code hidden in the four corners of a character. What looks like pure chaos on the surface is actually built on layers of elegant, interconnected systems.
And that leaves us with one last thought to chew on. The four-corner method was this amazing analog algorithm built to navigate a sea of information. And it just makes you wonder, doesn't it? What are the invisible codes we use today? Think about it, the algorithm that sorts your social media feed, or the one that powers your search results. What are the hidden rules and the secret building blocks of those systems that we rely on every single day to make sense of our world? Thanks for joining me on The Explainer.